All right, first thing as always, stop this video right now and print these notes out before you watch this video, if at all possible. Go ahead, stop the video. All right, I'm going to assume you have these notes in front of you now, if you're able to. And I would like you to try to do problems 1 through 3, not number 4, just 1 through 3. Stop the video, try those 3 problems now. Okay, I hope you tried these. I'm sure you have some faint memories, at least of these 2 words, but you might not remember clearly or exactly what they mean. To say that 2 angles are complementary means that they add up to 90 degrees. To say that they are supplementary means that they add up to 180 degrees. Add up to, add up to. These are the key phrases. Because oftentimes when I ask students, what does it mean to say that 2 angles are complementary? Here's what a student will oftentimes say in reply to me. Listen carefully. They'll say, they're 90 degrees. And I'll say, they are 90 degrees? That's what I heard you say. Is that what you meant? They are 90? Like each one of them is 90? Because that's different than the 2 of them adding up to 90. All right? So don't say they are 90, because I don't want you to fool yourself. They must add up to 90. 2 angles are complementary if they add up to 90 degrees. And we don't even have a word for 3 or more angles adding up to 90 degrees. We wouldn't say that 3 angles are complementary. Complementary is a word only applied to 2 angles and only if they add up to a total of 90. Same with supplementary. All right. So for these angles below, name 2 complementary angles. Well, we'd need to find 2 angles that add up to 90 degrees. So angle DEF and angle JKL, they add up to 90 degrees. This angle right here, angle MNO, this is not a complementary angle. That phrase, a complementary angle, doesn't even make any sense. Complementary is a word that is only applied to 2 angles. Okay, so there's no such thing as a complementary angle. 2 supplementary angles, angles that add up to 180, that would be angle ABC and angle PQR. That would be the only example of supplementary angles from this list. Okay. Okay, for number 4, I don't even really want you to try this. If we were in class, I'd give everybody some patty paper, which we would have learned to use to do rotations in Unit 1, but we're skipping that this year. My point of asking students to do this is that when they rotate this 180 degrees, they're going to get a segment that goes in that direction, in the exact opposite direction. Their B prime would be over here. And then what I do is with the students, I say, suppose you had stopped rotating this ray right there. You had only rotated it that far. Okay. I don't know how many degrees that is. I'm just going to put an X there. But then suppose you resumed your rotating until you got exactly 180 degrees around. And I don't know how many degrees that rotation is either, but here's what I know for sure. This X plus this Y, this number of degrees of rotation plus that number of degrees of rotation must add up to 180 degrees of rotation. Okay, and it really doesn't matter where we stopped rotating before we resumed. Those 2 angles, because they are forming side by side a perfectly straight line, those 2 angle measures must add up to 180 degrees. I have no way of knowing how many degrees X is or Y is. And I remind you from the 3.1 lesson, can't even really say that this angle is less than 90 degrees and that angle is more than 90 degrees, well, I suppose I might be able to say it if it's in a graph, but when it's in free space like this, we don't even want to assume that that is an acute angle and that is an obtuse angle. It may seem like a silly rule, I know, but it is a rule you have to learn how to play by, okay? So going over to the back page then, once again, I'm going to remind you of a couple things and then ask you to stop the video and try all of these problems. The reminders are that you may and should assume that any line that appears to be perfectly straight is in fact perfectly straight. You may not assume that angles that look like right angles, in fact, are right angles, unless you have some indication in the diagram. Okay. You may also not assume the relative sizes of angles. You may not assume that one angle is bigger or smaller than another, or even the same size as another. You may not assume angles are acute or obtuse unless you have indications about those things in the diagram, something written in the diagram to tell you that one angle is larger than another or equal to another or acute or obtuse or something like that. So with those reminders, pause this video now and take whatever time you need to try to answer these 6 questions. Okay, so here are my answers. Angle ABC, that's this angle here, plus angle CBD, that's that angle there. So this might be, we might call that X degrees, we might call that Y degrees. I cannot know what either one of these angles is individually, but for sure, because of that right angle mark, they are adding up to 90 degrees. Okay. If that right angle mark were not there, I would not know what these two angles add up to. Okay. How about this one here? Well, we may assume that this is a perfectly straight line. So this is exactly what I was talking about on the front page, that once again, I don't know how many degrees in that angle, which appears to be acute, but I'm not even 100% sure about that. I don't know the number of degrees in that angle, which appears to be obtuse. But again, I can't even really be sure about that. But for sure, I can assume that this is a perfectly straight line. That's just the rules of high school geometry. If it looks straight, you can assume it is straight, and therefore these two angles must add up to 180 degrees. Okay. How about the measure of angle ABC, which is this angle right here? I'll put an X right in there. Well, again, we can assume that that is a perfectly straight line, and therefore that this whole amount of rotation from here all the way to there is 180 degrees. Subtract that 140 from that 180, and we have what must be the measure of angle ABC. My guess is most all of you got all 3 of those right, and now I'm going to catch you. So heads up, okay? Angle ABC, that's this one angle here. It's this 70-degree angle, okay? How about the measure of angle ACB, this angle down here, which I'm going to put an X in? Do we know the value of X? Do we know the measure of this angle? Answer, no, 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 we do not. Okay, for sure, I agree with you. It appears to be the same size as this angle over here. But without something in the diagram telling us that these angles are the same, you may not assume that they are the same. Oh, wait, Mr. Nortillo, you might be saying to me, isn't that an isosceles triangle? Well, we haven't talked about isosceles triangles, but here's the answer to that. Maybe it is, and maybe it isn't. Okay, it looks like it might be an isosceles triangle, but didn't I say this in the last lesson also? Looks like is almost never a good enough reason to come to a conclusion when you're doing problems in this course. Sure, it looks like an isosceles triangle, but do not assume that it is. Do not assume that this angle's the same size as that just because they look like they are. I have no way of knowing what this angle's measure is. Therefore, the sum of these two angles cannot be determined. Remember that abbreviation from last time? Cannot be determined. Okay. How about these two angles? Angle ABC, which is right there, I'll call it X, and angle CBD, which is right there. Should I call that X also? No, I don't have any indication in the diagram that this is the same as that. I have to call it Y. What do these two add up to? Do they add up to 180? No, because this is not a straight line here. This total rotation's not 180 degrees. This sum cannot be determined. Okay. And now finally, this one here, angle ABC. Where's that one? That one is over here. I'm going to call that X. Where's angle PQR? Oh, it's over there. I'm going to call that Y. This appears to be obtuse. This appears to be acute, but I don't know for sure. What do they add up to together? I do not know for sure. Cannot be determined. If this bothers you, let me point out that if I had asked you for the sum of X and W, if I had asked you for the sum of these two angles, you could have told me 180 degrees, but I didn't. Or if I had asked you for the measure or the sum of these two angles, I'll call this H and Y, you could have said 180 degrees. But I didn't ask you either of those questions. I asked you for the sum of this angle here and this angle here. And here's what you don't know in this diagram that you might have assumed. Let me put this back in here and call it W. You might have assumed in this picture that angle W and angle Y are the same. Well, first of all, they don't even look the same, do they? I mean, isn't this line slanted over a little bit more than this one? Doesn't this angle appear to be a little bit larger than that? Now, I don't know that this is larger than that, but I sure don't know that it's equal to that. Okay? If I had some way of knowing that W and Y were exactly the same size, then X plus Y would be the same total as X plus W, which would be 180 degrees. But there's no way to know that W and Y are the same size. Okay. Now, here's what we're going to talk about in the not so distant future. If I somehow were told or knew that these two lines were parallel to each other, then we would know that this angle Y and this angle W are the same. But again, first of all, they don't look parallel to each other. But worst of all, we're not told that they're parallel to each other. Okay? So the answers to all of these down below are cannot be determined. All right? That's the end of the lesson here. Let's see. One more thing here. One more thing I want to point out. Because I see occasionally students do this on quizzes. This problem right here is asking for the sum of two angles, only two angles in this triangle. There are three angles in the triangle. It's asking for the sum of this angle here and this angle here. This angle name right here refers to a single angle in this picture, right? Just one angle. This is not referring to angle A plus angle B plus angle C. This is a single angle name, and that angle's measure is 70 degrees. That's it. Okay? All right. It's the end of the lesson. Good luck on the homework.